Determining density, moisture, and compaction of soils just became a whole lot easier. Now, with Humboldt's electrical density gauge, the EDG, you can make these determinations in less time, with less work, fewer regulations, and no certifications, all while reducing the overall costs involved. The nuclear-free EDG allows you to quickly and accurately make determinations while freeing you from the regulatory constraints of nuclear gauges and the intensive labor and consistency concerns associated with sand cones. The EDG can be used anywhere there is a need for density measurements, including roadbeds, foundations, excavations, retaining walls, and earthworks of all types. The primary advantages of the EDG are: it does not require a highly trained or licensed technician for operation. It does not require special handling or regulatory compliance for hazardous materials. It is easy to learn and easy to use with its intelligent step-by-step menu, guiding the user through the testing process. It is lightweight, easily transportable, and is not labor-intensive. It is accurate and repeatable, with results that mirror known testing methods, including an ASTM spec, D7698. To get an idea of how easy it is to use the EDG, let's compare actual testing procedures using the EDG, a nuclear gauge, and a sand cone. First up, the sand cone. Typically, sand cones are prepared in the lab and transported to the site. Here, the technician performs the test and returns the samples to the lab for weighing and a moisture test to be conducted, or the technician can do these tests on site with the use of a scale and a drying oven, which would then yield density and moisture readings. Percent compaction could then be calculated based on Proctor test data. With the nuclear gauge, a technician can perform a test fairly quickly and can get immediate values of density and moisture. Compaction values can also be generated if Proctor test data has been entered into the gauge. With the EDG, a technician can perform a test quickly and accurately to get immediate values of density and moisture. Compaction values can also be generated if Proctor test data has been entered into the gauge. As you can see, the EDG is actually the fastest of the three methods, with the nuclear gauge and the EDG being closely matched, especially when using fast mode measurements with the nuclear gauge. The sand cone, however, involves a longer test time, as well as the added time involved in weighing samples and performing moisture tests in the lab. The electrical density gauge measures the dielectric properties and moisture levels of compacted soil using high radio frequency, traveling between darts driven into the soil being tested. The dart's depth of penetration positively determines the depth of measurement. Darts are available in 4, 6, 8, 10, and 12-inch lengths to correspond to different lift heights. To ensure accuracy, user-generated soil models of actual materials should be developed and programmed into the gauge prior to usage. The EDG uses these soil models as a calibration reference during the testing procedure. Soil models are essentially a curve that is developed using the EDG to take readings of a particular material at different levels of compaction and moisture. Once this curve is developed, it can be stored in the gauge for future use, as well as transferred to other gauges for others to use. A typical soil model is comprised of 3 to 16 readings to make up the curve. The EDG then uses this curve to determine moisture and density levels for a specific soil. Similar to nuclear gauges, Proctor test numbers for optimum compaction can also be entered into the gauge, which allows for compaction percentage to be automatically calculated and displayed. Soil models are also used by the EDG to flag readings that are outside the known soil model curve. This feature can alert the technician to a potential problem of an incorrect or sub-quality material being used while he's performing the test. The EDG has a load of features designed to make transporting, testing, and gathering information as easy as it gets. With the new EDG, you can control all the gauge functions from either a 4.3-inch touchscreen or the menu-driven touchpad. The EDG is powered by a rechargeable lithium-ion battery, which provides up to 60 hours of runtime. The car charger is also available. The EDG is equipped with GPS, which keeps track of the location of your readings to ensure the validity of tests. The new EDG is Bluetooth enabled, so it can connect to your PC for downloading test results via wireless technology. In other words, no more cables or gauges on your desk or in your vehicle. Bluetooth provides a reliable and secure connection up to 30 feet. The EDG also has a USB slot, which provides a convenient way to capture test data and take it with you, as well as provide an easy way to upgrade the gauge's firmware. Firmware upgrades are available via the internet from our website. EDG software will allow you to communicate effortlessly with your EDG gauges and only requires minimal setup by the user. The software provides a complete solution for the acquisition, storing, and presentation of job and soil model data. It allows your computer to communicate with all your gauges, download job data, create customized reports, upload soil models to all your gauges, input Proctor test data, view maps of test locations using Google Earth, and allow the use of time, date, and GPS stamps for each test. With the introduction of the EDG, you now have a viable alternative to the nuclear gauge and sand cone methods for determining density, moisture, and compaction of soils with its own ASTM spec D7698. So, if you had enough of dealing with and paying for the licenses, certifications, safety issues, insurance, and scheduling involved with the use of nuclear gauges, and if you want something a little less labor-intensive than a sand cone, but which also provides computerized automation, reporting capabilities, GPS, and a host of other features, look to Humboldt's electrical density gauge, the new era of density and compaction testing.